HVAC 360 is brought to you today by the Bling Corporation. Tired of your artistic ductwork design being hidden behind plain white ceiling tiles? Wish your exposed ductwork could be something other than round or flat ovals painted a matte black finish? Wait no longer. From the geniuses who brought you the Bedazzler comes Glamour ducts. Whether in tie-dye or rhinestone encrusted, or outfitted with cool LED blacklights, your design will never look more amazing. Clients won't stop talking about them as you take the spotlight away from those ego-driven architects. Some say high fashion and environmental comfort distribution have just had a love child. Its name, Glamour Ducts. Brought to you by the Bling Corporation. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, I'm either sharing lessons learned from the field or talking with industry experts. This happens to be neither one of those. I'm just going off a different topic suggested by a listener. This is for dedicated outside air systems. But I don't stop there. I want to encourage you to go down over to HVAC360.com and sign up for my growing mailing list it's a community of people just like you. As an added bonus, I know I've been talking about this for the past couple of weeks, but I'm going to start a free webinar series launching in early 2019. Now, there's only 100 spots available. They're going to go first come, first serve, and for those people who are on the list, those people are going to have the first opportunity to sign up. All right. So what's up for this week? This week I kind of spilled the beans already. We're talking about dedicated outside air systems, also known by their street name, DOAS. All right, so why DOAS in the first place? Before we get to those kind of rationalizations, let's kind of work up to it a little bit first. Say if you had a space, you could have a constant volume heating and cooling rooftop. This is similar to what you might have at home, and you have really no outside air. Now, in a commercial sense, that wouldn't meet code, but you could technically do it. And you'd have a heating coil, you'd have a cooling coil, and those would handle the sensible, the dry bulb kind of temperatures that you're looking at. But you'd have to do something about the latent heat, and that's the humidity in the space. Now, the humidity is really controlled by the cooling coil. That's really the way that you handle it in these type of situations. But realize that the humidity is only taken care of when the coil is energized. That's because the coil gets cool enough to be able to condense the humidity out of the air and to wring it out. As people, we are just kind of constantly spewing humidity into the air. And not only that, but you get humidity driving in from the outside conditions parts of the year. So now that is a very simple system. But what if you wanted to take advantage of some of the more temperate times of the year? Just like you'd open up a window in your house, you want some way to get that free cooling so you don't have to run your DX coils or your heating coils so much. And they do that in air handling units by adding an economizer section. So the economizer is a way to introduce outside air and relieve the return air. So you don't have to condition it, just like we were talking about. This free cooling is really kind of an enthalpy trade-off. Now, what is enthalpy? If that's throwing it off, you think about enthalpy as work. So would it be harder for the unit to take the return air, condition it, and then discharge it at, say, 55 degrees and whatever humidity? Or would it be easier to take the outside air and put it through the unit and discharge that at 55 degrees? What would be more economical? And based on certain algorithms and the temperatures, they can do a rough calculation and determine which would be more efficient. And if it's more efficient to use the outside air, then it would economize at 100%. So that is kind of how it's really decided at the unit. Now, in the United States here, there's areas of the country, a lot of warm and moist areas, that economizers don't make much sense. You don't get a lot of those times when you can take advantage of those outside air conditions without The enthalpy really never. That's never a choice when it compares the two, outside air versus return air. It always gravitates towards the return air. So the economizers in some certain areas, you'll never really see them up on the rooftop. Now, that is just from a pure energy standpoint. Now, when we talk about ASHRAE 62.1, that's the ventilation standard, remember. Now we have to account for some sort of minimum outside air. We're talking about indoor air quality. We have to have a minimum amount of outside air for each occupant. Now, when we're talking about a building, that amount is different for different spaces. The problem is you can't really direct the outside air to go in one space versus another, and we know they're not all equal. But the amount of outside air that we're taking in at the unit is a percentage of the total airflow for the unit. So that sometimes when you deliver that to a space, you're taking spaces that are underoccupied and you're overventilating them. Or you're taking spaces that might be heavily occupied and you're underventilating them. So you really don't have that option of telling the outside air where to go. I had one of the sponsors in one of the previous podcasts was the duct arrows. You really can't put the duct arrows in the ductwork and tell the airflow or the outside air where to go. It just doesn't work like that. So, I mean, to address this, instead of doing anything crazy, the next kind of step in the evolution, when we're trying to ventilate with a standard system, is to put in some sort of demand control ventilation. Now, this monitors the CO2, so it knows when spaces are being underventilated and overventilated, and it really works with a unit there to make sure that the CO2 levels are appropriate. Now, what DOAS does is something special. It's a way to decouple the system and separate that out. And so you'd have a comfort cooling component and you'd have a ventilation component. And they wouldn't be together in one air handling unit. You'd have one side that would account for all the outside air and treat the outside air. Typically, when you have air handling units, you always have issues for accounting for that latent cooling, that humidity, because typically you're going to first select a unit based on the sensible. Then you're going to go check and make sure that it has enough latent capacity in the coils to handle a building. But that's not the case for DOAS. I always find it interesting to hear owners talk about humidity levels and humidity control. They think that just because they have air conditioning, that they have humidity control. And with a traditional HVAC unit, it's purely passive. Like I said before, it's only when the coil is on and it's nice and cold and wringing out moisture. And that's a big component. Especially if you can have something a little bit different, and that's with DX coils. You could have a chilled water coil and have it be more consistently dehumidifying. There's some certain spaces, and that's the advantage of having a chilled water coil versus a DX. You're going to have places like a hospital that would be using chilled water. And they would use this because they could modulate the amount based on the capacity, but you'd still keep that constant temperature of 55 degrees. So you would keep, cooling the coil and condensing on that coil and keeping the humidity level within a certain range. But with a DX coil, it's not that easy. Some of the newer ones, and this is actually what's being used in the DOAS units to control the humidity, they have some ways around it. But the old DX was either on or off. Or different stages or different parts of the coil would be on or off. So it really didn't work that well. So I guess at what point does a DOAS make sense? Now, I've heard it said that, when your sensible load is about 70% or more of your total load, that's when you want to use a DOAS system. Now, a DOAS system, basically, it does a better job and it saves more energy than on latent sensible cooling than your more traditional units. A lot of this has to do with energy recovery, but that doesn't necessarily have to, always be the case. The one thing you're not really going to save the fan energy. This outside air, the amount of air that you move, that's kind of a wash, but it does handle the sensible and latent cooling better. And the whole goal of this for the DOAS unit is to supply neutral and dry air to where it is needed. So you're going to condition the air and you're going to send it off to the appropriate amounts based on the ASHRAE ventilation 62.1 and handle that appropriately. So a DOAS unit is typically not just used alone. It is typically part of a bigger system that are married together that act as a complete solution for a building. Like I said before, this one handles the ventilation, and then you have a component of your system that handles the more of the internal loads. It'll handle enclosure loads, and it'll handle the people sensible loads. Now, some of these systems that you can actually marry it to, things like active and passive chilled beams. You might have single zone air handling units with hot water and chilled water coils, some 4-pipe fan coil units, so to speak. You'd have VRF systems, or variable refrigerant flow systems, or you'd have ground source heat pumps. All these, could be married to the dedicated outside air system and provide a great solution. Now, I think the one thing that you're going to note is that they've gotten away from using ductwork. These are not air type systems. They're more of a chilled water, heating water, refrigerant based system. And why is that? Now, I was watching a couple of YouTube videos, and it was interesting because this one particular one from Titus said that a 1-inch pipe can supply as much heating and cooling capacity as an 18 by 18 inch duct. Now, that's pretty amazing, especially when you're looking to, the architects are always looking for ways to save space. This is one of those ways that you can minimize the space that you need for a system just by delivering, hydronic heating and cooling just through piping. And also another fun fact that they mentioned, that water really can move the same amount of thermal energy as a fan, but using 1/7 the operating cost. So not only is it more spatially efficient, but is more efficient operating cost-wise. So, and typically, too, the ductwork that you use for a traditional system is like way oversized. Typically, you're going to use it for cooling loads. It's going to be sized for cooling loads. Heating loads in general are going to be, because you have that larger delta T to work with, you could get away with smaller ducts, but because there's only so much delta T you can work with on the cooling side, the ductwork has to be a certain size. So it really doesn't help. I mean, the ventilation is only a small part of that, so that's why you can shrink that ductwork super small compared to the regular size traditional air handling unit ductwork. Few of the last comments I'm gonna point out here. The dedicated outside air systems really like to control themselves. These, because they're really smart and they're really trying to control the humidity and cooling, along with an energy recovery wheel at times. They have a lot of components, and so they like to kind of take care of themselves. They'll have a lot of intelligence integral to the units. So a lot of times you're gonna rely on just monitoring monitoring the points. You're going to be able to change the schedule, and you might be able to change the set points that you actually deliver this neutral dry air to, but you really can't do a lot more with them. They're kind of packaged, and they'll do what they want to do when they want to do it, because they have their own internal logic and algorithms that are already preset at the factory. So commissioning wise, they're not so easy to commission. They're kind of simple. You'd like to do more with them, but you really can't, is what I'm trying to say. Another thing that the DOAS units, they have heat wheels. So that makes the unit, depending on the configuration and the amount of outside air that you're trying to condition, that might make the unit taller. So you have to consider maintenance in this. Because you have typically on either side of a energy recovery wheel, you're going to have filters. So you're going to need to be able to change those filters. And so does the maintenance staff need a ladder to be able to get and reach the filters on the top deck of some of these DOAS units? Some of them are small, some of them are single level, so they're real easy. But you gotta be careful about when you select your unit, how tall it is, what kind of maintenance is going to be required for that unit. So keep that in mind. Now, talking about energy wheels, some of the energy recovery options for the DOAS include things like total energy wheels. So that's going to be, when they say total energy, that's going to involve a exchange of energy that is both sensible and latent. So you get to, with some of the outside air, when it's humid outside, you'll be able to knock down the humidity, so you don't have to treat all that humidity with your cooling coil. And during the winter months, you get to add humidity to the incoming air, so you don't lose it all. You have dual wheel systems. You also have fixed plate heat exchangers, and then there are heat pipes. Now, again, some of those are sensible only, and some, like the total energy wheel, that covers both sensible and latent heat. Is interesting because I know that when I thought of this topic, I had to harken back to the K through 12 net zero energy advanced energy design guide that we touched upon a couple podcasts ago, and I went and reviewed that a little bit, and a couple of tidbits that poked out. It was interesting to note that for the net zero K through 12 schools, that all the HVAC systems, they gave you three different options for the HVAC systems, but they were all coupled with DOAS units. So if you're thinking to yourself, okay, when do I use a DOAS unit in my design? If you're thinking about high energy efficiency, you really want to decouple this ventilation load from the rest of the building. And it totally makes sense, especially when you're dealing with occupant loads that are not consistent. They're not all the time. When you don't need that ventilation, you can just shut it off, and you can save a whole bunch of money. And you're just conditioning the space regular. Another thing that it said is that, especially with net zero, that it's very tempting to deliver outside air at 55 degrees. Now, why would you deliver outside air at 55 degrees to the spaces? Well, that's because you can dehumidify it more. You can provide that nice dry air. But the key is that you want to provide neutral air. You don't want to have to do too much to it. You want to be able to provide neutral air, because if you deliver 55 degree air to a space, and it recommended actually delivering it to the space itself and not necessarily the mechanical system, but delivering it to the space itself in a neutral temperature, it prevented overcooling because you're going to be able to provide that neutral air. It's not going to overcool the space. It's not going to overheat the space. It's neutral. So that resists the urge, especially when you're trying to save energy and you don't have to reheat the air. Just let some of the, because the existing HVAC system, the one that you've decoupled it with, whether it be the VRF or the fan coil or the ground source heat pump, allow that to do a little of the dehumidification for you. So don't try to do it all with the dedicated outside air unit. Supply nice neutral air. And so that was one of the tips that they had for the DOAS units in that design guideline. All right, well, that's it for DOAS units. Thanks so much for listening. I hope this was helpful. If you know anybody who's looking for more information about this topic, consider passing this episode along. I'd appreciate it. If you're not a subscriber, consider joining the growing community of people just like you at HVAC360.com for more weekly goodness. And I'd be greatly honored, as always, if you'd consider leaving me a rating and review on Apple Podcasts. I'll certainly give you a shout out when I see your name. All right, well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.